Let me just clear my screen again. Today we're doing isomorphic strings. This is 205. Let's just jump in. Given two strings S and T, determine if they're isomorphic. Isomorphic if the characters in S can be replaced to get T. All occurrences of a character must be replaced with another character. Preserving the order, no two characters may map to the same character, but a character may map to itself. Okay, so some important things. No two characters may map to the same character, right? But a character may map to itself. This looks important. Let me just... two strings are isomorphic. This is our main rule, right? This is what isomorphic means. Whatever, two strings, S and T, right? So we want to replace all the letters. If the characters in S can be replaced, we want to replace all the letters in S, right? So yeah, we're gonna walk through this example just so we don't get confused. Characters can map to themselves. I don't think that sounds important, but immediately when I'm reading this, I'm like, okay, it sounds like we can just build some sort of dictionary, right? All occurrences must be replaced with another character. You have to preserve the order, right? So another thing right off the bat, okay, if we're preserving the order and all occurrences must be replaced with another character, I immediately know that both strings should be the same length, right? Otherwise, it doesn't make sense, right? You're preserving the order of the characters and you're replacing all the characters, so they should equal the same length. So let's look at the examples here. Yeah, they're always the same length, right? So, all right, cool. Let's look at this example. So we have egg. We also have add. Also, real quickly, let me look at these constraints. So the length of S, okay, cool, perfect. They tell us that the lengths of both are equal. It's only going to be ASCII. That's helpful. And s.length, s.length will, yeah, it's always going to be at least one letter that we're getting, right? Cool. So that's good to know. Let's walk through this one. Let's just see here. So we have E and we have A. So if I want to build a dictionary, right, I could just say, okay, E should map to A, right? Let's say I'm doing this in Python, so it's gonna be, actually a dictionary. E will map to A, right? So as I'm walking, X is my pointer here. As I'm walking from, I'm looking at both, right? I know that I've never seen E before, so I can move. And now I've never seen G, so I'm gonna go ahead and store that, right? G to D. And then I get to this one. I've already have a G. I just basically need to check if D if whatever the value that I already stored in G matches up with that, right? So this is S, right? And this is T. So we're always replacing the letters like this, right? So E should always map to A. Now I wonder, let's say I had this, right? What happens? I'm gonna get to, oh no, that's not what I was saying. Or that's not what I was thinking, because we already have an E here. What happens if we have an X here? Well, I know that I had never seen an X, right? But technically we've already seen D. So, okay, right here. No two characters may map to the same character. So that signifies to me that there is a two-way relationship here, right? E points to A, but A also points to to E, right? If you think of these as nodes, this is like a undirected almost connection between them, right? It's going from E to A, and then A also points to E. Characters can map to themselves. Yeah, so that's fine, right? That's just saying, like, if we had something like this, right? X can point to X. But in the example I just showed, if we had this equaling this, we run into an issue, right? We can't store D because we've already used it. And so immediately, sorry, not immediately. I say immediately a lot. So what I'm thinking is I should have two-way relationships. So I should have two dictionaries, right? E is going to point to A, so that means that A should also point to E, right? Same thing. D should point to G, right? That way, when I get to the second occurrence here, I'm going to say, okay, in this dictionary for S, is there an X? No, there isn't, right? But is there in this dictionary for T, did we already see D? Yes, we did. And then it points to G. So we do a check. Well, does G equal X? No. So by definition of this, no two characters may map to the same character. We already know that this is not isomorphic, right? Let's look at this other example real quickly. So foo and then bar. So F points to B, O points to A, O points to R. Yeah, so this is not, I don't think we need to step through this. We already know that this is just a one-way relationship here, right? Because O is pointing to both A and to R. But it's not showing us the other case here. Let's see, does paper and title show us that? Paper and title. P points to T, A points to I, P points to T, E points to L, R points to E. Hold on, E is going to point to L. So we're always going to be replacing E's with L's, and then E is going to replace R's. No, that's also fine. Yeah, so that's why this is true, right? One-way relationship. The case where it would not have worked if this was L, right? Because if you think about it, I'll walk through this one. Let's just walk through. So I like to do this during interviews, is like think of base cases but shorten them. That way you have enough time to explain, right? Because time is definitely of the essence in the 30 or 40-minute interviews that you get. So E points to L, right? Which means that on the next one, R cannot point to L, right? According to this, no two characters can map to the same one. So in this situation, E and R are both mapping to L, right? And the only way to see around that is if we had L pointing to E in another dict, right? Cool. Time and space. So time, we're just walking through S and T, right? So I would say time is going to be what? O of S plus T, right? I'm using a plus because actually, never mind. S and T are always equal to each other. So this can just be O of S, right? Technically, this would be S plus S, right? Or 2S, but that's constant, so that drops. This is just O of S. What else? We have space, which we know would, we're definitely going to need space to save this dictionary. However, well, it tells us that it must be an ASCII character. So this is going to be what, O of 26, right? That's constant. So I think we could just say that that's O of 1, right? Space is never going to be O of S because, you know, worst case scenario, O of S is every single every single letter in the ASCII, which is what, 20, or I guess it would be 50, whatever that math is, 26 times 2, if you consider like capital letters. I don't know. But yeah, so I think that that is time and space. Let's code up this solution and then we can check. So we're just walking through S and T, right? So I'm just going to say for I in the range of S, length of S, give myself some space. Let me make 2 dictionaries. So S dict and then T dict. Cool. So I definitely want S of I and T of I, right? I'm doing some checks here. So I'll say current S maybe, the current T. And what am I saying? I'm saying, okay, if current S is not in S dict, and then if current T is not in T dict, right? So let me refresh. What are we checking? So if E is not in the S dictionary, we want to add it, right? So we're saying that S dict of current S will equal current T, right? Other way around for this one, be current S, right? If it's not in the dictionary, then input, and then we still need our check, right? If it is in the dictionary, we could put else here. So if current S is in S dictionary, we are going to check S dict current S we're checking, does it equal current T, right? So if it is equal, then we continue. But if it's not, so if it's not equal, actually, let's write that better. If it's not equal, right, then we return false. And then let's look back at our example here, right? We had E, G, G mapping to ADD, right? So E must point to A, and G must point to D. So on each current, I'm checking if current S, so E, meaning it is in the dictionary, right? I'm sorry. So yeah, let's just walk through this, right? So in the first one, E is not in the dictionary, so we store it. We skip over this, and then we also ask, is A in the other dictionary? It's not, so we're making this other, let me pull this down. A points to E, right? Cool. Okay, then we go to our next letter. We have G pointing to D, and then D points to G, right? So we need to do a check here, right? Current S is not in, so we store it. Current T is not in, and then when we get here is when we start doing our checking logic, right? So current S is in S dict. So we check, okay, does S dict of current S match what's stored? So the value that comes back from this, does it equal current T? Well, current T is D, and the value that's stored is D, so this matches. And then so, yeah, we're gonna also need this check here, right? If T dict of current T does not equal current S, return false, right? Otherwise, if we reach the end of the string, we know that we have got the right answer, right? It should return true. Let me just test out that last case, right? So I was saying that if we had a X here, right? When we get to this case right here, so we have G and we pointing to D, D points to G, perfect. Now we get here. And get here. So if current S is not an S dict, so I'm storing first X to D, right? So this skips over because X is not in the dictionary. Then I say if current T is not in T dictionary, well, we know that it is, right? There is a D, so we check, does T dict of current T, which is D, equal current S? Well, current S is X, so we should return false here. Yeah. Let's see here. Is there anything we can condense here? No, I don't think so. That looks okay to me, right? Let's see. Let's try running this. Cool. Accepted. Submit. Awesome. Did this a few days ago and I already kind of forgot it. So, yeah, just trying to actually just put up videos of actually my first attempt from now on, just because I think I just want to put more content out, you know, and stop worrying about having it be perfect. So yeah, I hope you enjoyed that. See you next time.